In example 1, we're asked to find the central angle of blood type A. So recall, a circle has 360 degrees. And then we know that type A represents 28% of our entire circle graph here. So what we can do, we can take our 360 and we can multiply it by our 28%, which we have to write as a decimal. So we can write this as 0.28. And then this will give us 72.8 degrees, which represents 28% of our total circle. So our central angle will be 72.8 degrees. All right, in example 2, we're given that a pizza is cut into 8 equal pieces, and we want to know what the central angle for each slice is. So we can think about this. We know that there are 360 degrees in a circle, and if we're cutting it into 8 equal pieces, we can divide our circle by 8, and this will give us the central angle for each slice. So when we do this, we get that our central angle is 45 degrees for each slice. All right, so we're looking at example 3, where we're asked to find the central angle of this circle. We're given the arc length of 6 inches, and we're given a radius of 3. So recall our formula for arc length. We have S is equal to theta divided by 360 times 2 pi r. So we can fill in the given information that we have here. So we know our arc length is 6, so we can plug that in for our S. And then times 2 pi, and our radius is 3. So at this point, we just need to rearrange our equation to solve for theta. So we can start by multiplying by 360 on each side. And if we do that, we get 2,160 is then equal to theta. We can multiply our 2 and our 3 times 6 pi. And then to get theta by itself, we can divide by 6 pi on both sides. And then these will cancel out, leaving us with just theta. And one thing, if we plug this into the calculator, make sure that we put the 6 pi in parentheses, so it'll follow order of operations. And when we do this, we get 114.6 degrees is equal to theta. So our central angle is 114.6 degrees. All right, in example 4, we are asked to solve for the arc length when we are given the radius and the central angle. So we can use our arc length formula. We can plug in 60 degrees for theta. We can plug in 9 for our radius. So if we do this, we get S is equal to 60 divided by 360 times 2 pi times 9. So if we think about combining all of our terms on the top, we can multiply 60 times 2 pi times 9, and that's going to give us 1,080 pi divided by 360. And then when we plug this into our calculator, we get that S is equal to 9.4. So our arc length from P to Q will be 9.4. All right, in example 5, we are asked to solve for the radius, and we're given this diagram where we know our central angle is 40 degrees, and then it also tells us that arc length AB is 10. So we can plug 40 degrees in for theta, 10 in for our arc length. So we have 10 is equal to 40 divided by 360 times 2 pi r. So we can rearrange this equation a little bit to get r by itself. So first we can multiply by 360 on both sides. These are going to cancel each other out, and this gives us 3,600 is equal to 40 times 2 will give us 80 pi r. And then lastly, we can divide by 80 pi on both sides. So these will go away. And remember, if you plug this in on the calculator, to put 80 pi in parentheses, and this will then give us 14.3 is equal to r. So our radius is 14.3.